Morning, everyone. So this is not a talk about dogs, but yeah, I decided to sprinkle some pictures of my dog Hazel in this talk for those of you who are dog lovers, because not everything is about cats, right? So in case you don't know who I am, I've been living in Ireland for a few years, and I make stuff. I have some open source projects. I have a blog. I wrote the blog software that I use to blog myself, and I wrote a bunch of books, and I also work for Elastic. And maybe some of you have used the Python Elasticsearch package. I am one of the maintainers of that package, so maybe you've used some of the things that I've made for money. And Miguel Grinberg is how I sign into every social network, so you can find me everywhere if you need to reach out, including the Discord for the conference. So, okay. So why do we need another web framework, right? We have so many already. So there's a story that I'm going to try to make short about the why of Microdot. So 7 years ago, I moved to Ireland from the United States, and I rented a house, and this was in the summer of 2018. So I rented a house. The house came with this smart heating controller. I was very excited. I didn't have one of these in the States. So I was really looking forward to the winter to see how this thing worked, right? So this is I think that it's an Irish company that makes them, so most of you probably don't know them. But anyway, so this is the controller. There's two thermostats, one in the lower level of the house, one in the upper level in one of the bedrooms. And these thermostats measure the ambient temperature in the room where they're in, send the temperatures to the controller, and then you can see the controller has a 20 in the middle of that weird thing. So that's the target temperature, the temperature I want the house to be in, right? So based on the 20-degree target and the temperatures that these things reported, the controller will start the heating or stop the heating, the usual stuff. In addition to that, this device allowed users, tinkerers like myself, to send HTTP requests. So there's a web server somewhere in there that you can ask for things, or you can start or stop the heating. And it also supports SMS. You can send commands through SMS. There's a SIM card somewhere in that box. So anyway, very exciting stuff. So the winter came, and it didn't work that well, unfortunately. I felt many times that the house was chilly, so I had to start the heating manually. Other times, the heating was running, and the house felt kind of toasty, so I had to stop it. And so after some debugging, I found that the problem was that these two thermostats that were installed in the two levels of the house reported temperatures that were all over the place, that were not very accurate. I measured this with my own thermometer and determined that it could be off by plus or minus 3 degrees Celsius, which is too much, right? For trying to keep the house at 20 degrees, it didn't work, right? So I told the owner of the house, and she thought that I had too much of an American mentality, where at least she thinks that in America everything is super efficient, everything works, right? So she thought this is the way things work in Ireland, so this is fine, right? So I couldn't get anywhere with the owner. So normal people at that point would say, yeah, okay, whatever, I'll deal with it, right? So I hacked my heating controller instead, right? So basically, I'm going to go back for a second. So basically what I did is I changed that 20 target temperature. I lowered it to 0, which was the minimum it went, right? Which effectively disables the built-in thermostats in the house. They will never be able to start or stop or do anything with the heating, right, when the target temperature is 0, right? So then I built two of these. right? So the darker thing that you see on the right side of the picture is a microcontroller board. It runs MicroPython. That's one interesting feature. The second interesting feature is that it can connect to Wi-Fi and connect to my home network. Right? The white thing that you see on the left side of the picture is a temperature and humidity sensor. And then there's a few colorful cables that connect the two, which, to make the story short, allows Python code to get the temperature of the room. Right? So I built two, one for the lower level, one for the upper level, and every 5 minutes, I created a loop that every 5 minutes check the temperature and send HTTP requests as necessary to start or stop the heating, to the controller. It looked that it was manually being started and stopped, but I was doing it with MicroPython. This solved the problem. The second half of that winter, my first winter in Ireland, it was great. The accuracy on these sensors, by the way, it's plus or minus 0.5 degrees Celsius. It's much better than the plus minus 3 that I determined the built-in thermostats were at. So problem solved. Unfortunately, this created a new problem for me. Right? I wanted to know things. I wanted to know, what's the temperature right now? Is the heating running right now or not? How many hours did it run today compared to yesterday, this week versus a bunch of things. I wanted to know a lot of things. So initially I attached a little LCD screen to this device. I added it to the circuit and showed some stuff. It's a really, really tiny screen. But I had to get up and walk to the place where right. So what I really wanted is to find information about this thing from my phone while on the couch, while watching Netflix, very easily. And the solution for this is obviously that I wanted to host a web server, a little web server that will show me a little dashboard. Right? So I immediately went to search for web frameworks for MicroPython. And in the winter of 2018, 2019, there were none. So there were no frameworks. So things like Flask, even Bottle, which is a little bit smaller, all those things are too big for, which, by the way, I forgot to mention, I have this guy, it's right here. If you want to see one up close, find me after. Right? It's running. I'm going to show it in a little bit. So all those things don't run, A, because they're too big, and B, because the standard library in MicroPython it's a small subset of what the standard library of CPython is. So a lot of things are missing, right? So none of those things work, right? So a normal person will say, yeah, okay, whatever. It is what it is. So yeah, as you know, I created a web framework, right, instead, right? So I'm going to demo this to make sure that you get to see it. So let's see how this goes. So I have a terminal here. I apologize, I should have changed this to white, but yeah, we'll make the best of it. So this is running, it's right here, right? It's connected for power, and so that I can see a terminal. So basically, MicroPython is running in this thing, and I'm going to open a shell to operate the device, right? So I'm going to use our shell. This is a Python package that allows you to connect to devices, and that's the port, the serial port in which the device is connected. So now I'm inside this R shell prompt, and I'm going to start a Python REPL. So this is MicroPython. So my laptop right now is acting as a dumb terminal, right? Everything that I'm doing, it's running inside this little device, right? So I am going to reboot the device. So this the way I have this demo set up, the device, if I were to plug it not to my computer but to a wall, right, to a power adapter in the wall, it will boot into the web server, right? So I'm going to simulate that by rebooting it right now. So it starts, it auto starts, it runs a server. Obviously, before starting the server, it connects to Wi-Fi, and it shows me the IP address here. So it's 147.91. Right, so, I'm sorry. There we go. So 168, 147, 91, 8000 is the port. What did I do? Yeah, hold on. Yeah. I should trust 192, 168, 147, 91. There we go. Right, so if you wanted to know what's the temperature right here, right now, it's 24.4 degrees Celsius. And that's a bonus you have the humidity too. So I have to apologize for making it yellow. So in Ireland, if temperature gets over 20 degrees Celsius, people start to panic. It's really, national emergency, right? So I consider that yellow, not green. And I apologize if you disagree, but yeah, we're never going to agree on that. But anyway, so this works. I'm going to split. So this is the front end, right? This runs in the browser, and it sends requests to the device, which runs a little API, right? So I'm going to show you the API as well, since we're here. So this is HTTP 192. It's from, yeah, I have it from before, right? So that's really what what you get, right? So you get humidity, temperature, and the time. Which the time is interesting because these devices don't have, don't remember the clock when you unplug them. They forget the time. So this application, this demo application, connects to an NTP server to find the time every time, right? So that it can tell me when was the last measurement taken, right? So yeah, this is basically it. I'm going to stop this for a moment. So Control C. I'm going to exit the REPL and just show you. This is this is probably kind of invisible, right? So this is the file system in the device, right? So boot.py comes with the framework. I didn't touch it, not mine. And then config.py, main.py. Main.py is a magical name. It runs when you have a main.py in the device. It automatically runs it. So this is the Microdot application. Index.html is the front end, and microdot.mpy is the framework, right? Which is it's not .py because it's precompiled. This is something to make it a little bit more efficient, right? I precompiled the code. But anyway, this is how things work, right? So great. So I'm going to talk about the features of this framework, but I want to set expectations, at the right level, right? So these three devices are the ones that I usually work with the most. The top one, ESP8266. You have the cost. They're all very cheap, by the way, right? So the flash memory and the RAM, you can see. The flash memory, you can compare that to storage. This is where, in this device, you will install MicroPython itself, and where the file system is, right? So it's kind of a virtual hard disk, right? And then for RAM, 64K, this guy here, right? So this is the lowest microcontroller I found that has Wi-Fi, right? Which is kind of required if you want to build a web server, right? So there's many more devices that are even smaller, but this one is the lowest end of the Wi-Fi ones. And then there's a Raspberry Pi Pico and ESP32, which are a little bit more more powerful. Now, compared to this laptop, right? So the laptop has 32 gigabytes of RAM. You can check me on my math. I believe you need 500,000 ESP8266s to amount to 32 gigabytes. And if you wanted to go with the high-end one, the ESP32, you need 64,000 of them, just so that you get an idea of what the difference is, right? Good. So features. So the whole framework is in a single Python file. This is the core framework. And so it uses async IO. The reason it uses async IO is that this is the only way to do concurrency on these devices. There's no threads, no processes, no nothing, only async IO. So if you don't like async IO, you're probably not going to have much to do on, on microcontrollers, because that's the only way. So it uses Flask-style decorators. There's request and response classes, before and after request hooks. It gives you high-level access to query string form and JSON using dictionaries in Python. Very important, it allows you to work with streaming for requests and responses. This is important because many times you need to work with requests that are, the body of the request of the response is larger than the 64K that fit here, right? So you can create or read these bodies in chunks, right? And get to work with larger amounts of data. Supports cookies, static files. You saw that this is serving the index.html. And supports sub-applications, which is a way to construct applications in modules, right? Kind of the blueprint idea if you know Flask. And finally, it has its own web server with optional TLS if you want. So I hope, I'm very proud of all the stuff that I was able to fit in the core Microdot framework. I hope if I question some of you, you will have to think for a minute or two to say what's missing here, right? But the fact is that there are things that are missing. There's really stuff that's missing. So those things I wanted to have, but I didn't want to make this file bigger, because if I make the core file bigger, it will not fit on my low-end device, right? So as it is now, it does work, right? So I created a bunch of extensions. I consider them part of the framework. They're combined with the core to build a larger framework. One Python file per extension, and these are the things, right? So one is for multi-part forms if you want to do file uploads. This is extremely complicated to parse. It didn't make sense to add in the core because most people don't do this. WebSocket support, server-sent events, templates with a couple of, this is integrations with a couple of template engines. I'm sure you know Jinja. uTemplate is one that works in MicroPython. Jinja is too big, doesn't work. So basic and token authentication, if you want to do that. Secure user sessions using PyJWT. There was no PyJWT in MicroPython, unfortunately, so I wrote one and contributed to the MicroPython project. So there's one now. So you can do this even in these devices. User logins, similar to Flask login course, if kind of important if you're doing an API. ASCII support, this is for Python. If you want to run this framework on regular Python, you don't have to use the embedded web server. You can use the UVcorn or something like that. And there's a test client as well to write your unit tests. So, right. So there's actually more stuff. So I consider the documentation part of the framework. So everything, I'm kind of fanatical, and I document everything. And if anything is missing or is not explained correctly, it's a bug that I need to fix. So the documentation right now, I wrote it kind of, what is it? It's kind of like a book. I write books, right? So this is like a book. It's a guide. You learn everything, right? So I counted 9.2K words. Which at the average reading speed of 200 words per minute, you can read in 47 minutes, a little bit less, right? All of it. So testing for everything as well. And there's a bunch of examples. So very quickly, this is the repository, Miguel Grinberg /Microdot. Examples, so there's a bunch of categories here. All the examples are generally small and directed to help you learn one thing. This is the example that I showed before, which is probably the largest one. I'm going to show you super quickly the main, the start. So basically this connects to Wi-Fi, prints the IP address, starts a background job to refresh the weather from the sensor every minute, and then starts another background job with the web server, and then waits. And then you can see up there's the two routes, which are very much like Flask. This is probably not a feature, but a design principle that I follow. I don't want dark magic. So for example, an example of dark magic, in my opinion, is the application and request context in Flask, which very few people understand. So here you can see that all routes receive the request as a regular argument. So super easy to understand. Another thing, so these are two more examples. They show WebSocket on the left and SSE on the right. So this is what I like to do instead of dependency injection, which is a feature of FastAPI. So here you use a decorator that adds an argument that passes whatever you need to do, to implement your route. So you want to know about size, I'm sure. Okay. Let's do it. So there's a chart here with a comparison. So for the metric, I've used this clock utility. It's an open source lines of code counter. It detects blank lines, comments. It ignores all of that. So it counts lines of Python code. So this is Django, 110,000 lines, more or less. For Flask, I used Flask plus Verksoy because a lot of Flask is actually in Verksoy. You cannot separate them, right? So this is 15.5K. FastAPI has a similar relationship with Starlet. So this is a tiny bit smaller than Flask, 14.9. This is Pi, so 3K lines. And drum roll, this is Microdot. Microdot has 765 lines of code, believe it or not. And you can go check, you can keep me honest, right? So 765 for the core. If you do a full install on a device, that will be a little bit shy of 1,700 lines of code. So how can it be so small? So I'm going to give you I'm going to make it quick because I'm almost out of time, and this is my last slide. So in Flask, the process of processing these URLs that you put in the decorators, right, which can have dynamic components, and this is all done in the Verksoy.routing subpackage. It has a bunch of things, a lot of classes, root factory, and a bunch of others. There's classes for all the types that you can have in these segments, exceptions. Total, it's 1.3K lines of code. It's measured with the same tool, right? So in Microdot, the same thing. It's a little bit simpler. I implemented only the most important things. It still allows custom segment types like in Flask. It's a single class with just 2 or 3 methods, and it's 63 lines of code. Right, so I don't intend to support everything that Flask supports in terms of routing, but I intend to support the 20% that covers 80% of the use cases. And that's basically how you get to something that is this small. So at this point, really, a normal person would be satisfied that he created a framework that is probably, I don't have any data, but probably the most used in MicroPython. Right, there's a couple more now, right? So I'm not the only framework right now. But of course, I'm not a normal person, so I really want this to kick off also in Python, right? So what I would like people who are tinkerers to try it and let me know what things you're missing when you're using it, especially in Python, but of course in MicroPython as well. So with that, I finished my presentation. So thank you so much.
Thank you. Okay. Thank you, Miguel. So we have opened the question and answer session. So there is a mic. So anyone near the mic, you can use that mic. So anyone near me, so I can hand over to the mic. So please raise your hand if you have any questions.
Hi, Miguel.
Hello.
Thank you very much for your talk. As the framework is so small, I'm interested, how did you realize the plug-in system, which probably the usual ones are even bigger than your whole framework?
The plugin system, so these extensions that I mentioned, so they basically they work as separate entities, pretty much like in Flask. You have, for example, Flask login. You import it separately, but then it integrates with the core Flask. So this works in the same way. Each extension does its own thing. It does it separately from the core, and you import it only if you want it. In fact, if any extensions you don't need, I always recommend people to don't even copy the Python files to the device because they take space in the device, right? So you can import them, and they work independently. There's no really sophistication in the way this works.
So no hooks or anything? How to get it? Okay.
No.
Thank you.
Mm-hmm.
Okay, awesome talk.
Thank you.
I have two questions. One is that does this work on the Arduino platform with the LAN extension it has, like when you?
So it will work on the newer Arduinos, not the old Arduinos, Arduino Uno, those type of things. They don't have networking, and they're too small even for MicroPython. But yes, some of the newer Arduinos that support MicroPython and have Wi-Fi definitely works. Yes.
I was also checking the code on GitHub, and do you minify the code when you have like .py? Do you minify the code so it gets even smaller? Like
no. So the thing I briefly mentioned this, instead of minifying, which is sort of a JavaScript thing where you obfuscate the code, make it smaller. So sometimes that's not enough to make it work because when you copy Python code to the device needs to parse the code and generate the bytecodes. So the Python compiler, the MicroPython compiler, takes a lot of time and memory to run. So what you do for this is you pre-compile it in your laptop, right? And this is why I showed that the Microdot was a different extension, MPY. That's pre-compiled code, right? So this is bytecode already, right? So for example, on this device, which is the low end, the Python file will not compile in the device. I need to pre-compile it in the laptop and then copy the pre-compiled code. And that's basically how you do it. And there's even more ways, more tricks that apply to MicroPython, like putting it in the firmware with MicroPython itself. That's another option that you have.
Thank you for the presentation.
Yeah.
You showed how small devices could be, but what is the performance there? And how many requests per second it can handle and not break some background jobs that are running on this microcontroller?
Right. The performance on this particular one is not very good, right? So it's perfectly fine to have in your home, like I intended to, right, in my home, but definitely not something that you can use for to support a large number of users. So yeah, this you can pretty much watch it run. It's really slow. Yeah.
Okay, so I think we are out of time now. So let's thank Miguel. So please give him a round of applause.
Thank you. Thank you so much.